You ever try to learn something new and it just clicks? Like instantly? But then the next thing you try, it feels like you're hitting a brick wall. It's a feeling we've all had, right? Well, for decades, scientists have been trying to figure out why that is. They've been on this quest to actually measure, with math, what makes one idea a total breeze and another one incredibly difficult. So let's dive into that puzzle.
So this is the big question, isn't it? What really makes a rule easy or hard to learn? It's not just about a feeling, you know? Scientists are wondering if there's some kind of hidden code, a mathematical structure inside the information itself that our brains have to work to unlock. And honestly, if we could figure that out, it could change pretty much everything, from how we teach our kids to how we design the technology we use every day.
Okay, let's make this real. Take a look at this. On the left, you've got a simple rule, all red shapes. That's a piece of cake, right? You see red, it's in, done. But now, look at the rule on the right. All shapes that are circles or are not red. Whoa, all of a sudden your brain is doing mental gymnastics. You have to ask, okay, is it a circle? If yes, great, it's in. If it's not a circle, wait, you're not done. You have to check, is it not red? If so, it also fits. See? That tiny bit of extra logic makes a world of difference.
So to try and solve this puzzle, cognitive scientists came up with what they thought was a really elegant answer. They believed they could use the pure, clean language of logic and mathematics to get right to the heart of what makes something hard to learn.
The whole theory is built on this thing called a Boolean concept. Now that sounds super technical, I know, but it's actually pretty simple. It's just any category where the answer is a clear yes or no. Is this a dog? Yes or no. Does this shape follow the rule? True or false? These are basically the building blocks for how we sort and categorize the entire world around us.
And that brings us to the main event, Boolean complexity. The theory is this. You can measure how hard a concept is to learn by finding the absolute shortest way to write out its logical rule. A simple rule, like all red shapes, has a really short formula. A more complicated rule has a longer one. The core idea is that the shorter the formula, the easier it should be for our brains to figure out.
So the goal here is to find the most economical rule possible. Think of your brain like a computer, right? It prefers code that's efficient and clean. The theory goes that a shorter, more economical rule is just easier and faster for our brains to process. And if it's easier to process, well, it should be way easier to learn. Makes a lot of sense, doesn't it? And this slide just shows it perfectly. Look at step 1, that complex description. It's clunky, it's repetitive. You're saying A is true twice. The theory of Boolean complexity is kind of like a great editor. It looks at that mess and simplifies it down to step 2, the minimum description. It's the most streamlined, efficient version of the exact same rule. And the length of that final, minimal description is what was supposed to predict how hard it is to learn.
For a while, this theory was a huge hit. It seemed to explain so much. But you know how it goes in science? Things got a little more complicated when this beautiful, neat theory ran up against the messy, unpredictable reality of how human beings actually learn.
And let's be clear, for a good long while, this theory seemed to have it all figured out. The math lined up with the experiments, and everyone thought it was a major breakthrough. But then, researchers started to find a few cracks in the pavement.
And here's the moment it all started to wobble. A study came out, and this quote from the research says it all. Basically, when they double-checked the math and ran the numbers again, the complexity scores they got, well, they just flat out failed to predict how difficult people actually found the concepts in real-world tests. The elegant theory was starting to unravel.
Okay, now this table shows us exactly where things went wrong, and this is fascinating. Look with me. The theory, the math, predicted that type 2 concepts would be the absolute hardest thing for people to learn. But when they actually tested people, it turned out to be just medium difficulty. And here's the real shocker. Type 4, which the math said should be way easier than type 2, turned out to be the one that was actually the hardest for people to wrap their heads around. The prediction and reality just didn't match up.
But you know what? This is not a failure. This is actually how science is supposed to work. When a theory gets proven wrong, or at least incomplete, we don't just throw up our hands and go home. Nope. It means we get to ask even better, more interesting questions.
So that's the big question now, right? If it's not just about the raw logical length of a rule, then what are we missing? What else is going on inside our minds that makes one idea click and another one just not?
And that's exactly where the research is headed. Scientists are already chasing down some really cool new leads. There's one idea called information complexity, which looks at how much confusion a rule actually clears up for you. And there's another, categorical invariance, which is all about how sturdy a rule is. Like, does it still make sense even if you change things a little? These are the new frontiers.
So we're left with this thought. The simple, elegant mathematical answer, it just wasn't enough to explain the messy, beautiful, and sometimes frustrating complexity of our own brains. The hunt for a better theory is still on, and it just reminds us that understanding how we learn is one of the greatest and most fascinating puzzles of all.